Yes. Or find a tangent line.
There might have been find a tangent line, that one too.
I think it's 59.
59, was he a continuous differentiable one? There was a continuous differentiable one, and then there were some tangent line ones, if I remember right, that were particularly gross. And Adam was working through a few of them yesterday, so that's what he reminded of that. PK was working during 7th grade. She had her music and she was busting out. She's like, I'm getting them right! I'm like, yeah. But then she got to the end, she's like, I don't know how to do this. Okay. So anyway, hopefully most of homework was okay.
Yeah, most of them.
First half. How is it matching your derivative answers to the answers in the back of the book? Were you able to make a match pretty good for the first half? I mean, once it got to applications. Huh, John?
I never really did. Like most, my answers usually matched up like exactly.
Good. It wasn't that weird. It wasn't that crazy.
Yeah.
Okay. That's why, well, the competition, there were a few different. Number one, I wanted to show you guys like how nasty it could get as far as with some of those radicals or with denominators or with multiplying. But then I also wanted to, like, part one, can you just get something right? Can you just get a correct derivative? But then part two was, do you know how to simplify? Do you know where to simplify? So good. We're going to go ahead and cover notes all the way up until the forever card. We're going to cover notes all the way up until the forever card, which is going to be forever number 11, which is going to be the last forever card before a quiz on Thursday. So not tomorrow, but on Thursday. You might be like, why? Well, after this, we have another product rule card and a quotient rule card and a chain rule card, and we have more cards after this. And if you realize, don't we already have cards 6 through 10? Technically 7 through 10, but 6 was kind of important. So we already have a lot of cards, and then today we're going to have card 11. So I'm splitting this one up to do 2 forever quizzes this chapter. One of them on Thursday, and then one of them before the test, which I think is in October. It's in October. But like second week of October, I think, so not for like 2 weeks-ish. So that's why we need to have a forever quiz now, because if you can have these derivative rules memorized, which are a lot of you guys did pretty well on yesterday, it just makes everything go faster. So if you guys want to make a note of that, the calendar is now up to date. My ones who were like, we had to budge things just a little bit. So I think everything's up to date now. Velocity. Boop. Velocity. What does velocity stand for? Don't worry, I got you. Velocity is going to be a rate of change with direction. A rate of change with direction. Or you could also put it another way, a directed rate of change. Does that sound nice and smooth? A directed rate of change? If you're directed, when do you actually use that besides motion? I'm trying to find any to direct. Not as in a verb, but as in an adjective. Like not someone's directing you to do something. He was directed to, like he was commanded to, not like that. A directed rate of change. Any sense I'm going to make is awkward. It's okay, we'll come back to it. But a directed rate of change, it can be an adjective too. What is speed? Speed is just the magnitude of velocity. AKA, once again, it is a rate of change, but a non-directed rate of change. A non-directed rate of change. Average velocity, that's one that we saw last year, although you didn't call it average velocity, you called it average rate of change. An average rate of change is also known as average velocity equals f of b minus f of a all over b minus a. It was in chapter 1. And I think it was even on the chapter 1A class. I think it was way back then when you first saw the difference quotient. We talked about average rate of change is really just f of b minus f of a all over b minus a. And in a graph, well, you could also think of it as f of x1 minus f of x2. Well, we usually do it the other way. Last year, we probably saw it more like this. probably wasn't with B's and A's. And so if you think about it, f of x2 minus f of x1 over x2 minus x1, isn't that just a secant line? It's the slope of a secant line. So slopes are rates. Rates are how fast, right? So slopes are how fast, although in this one, it's not at one time, it's over an interval. So we're going to say over. I could say x is within an interval a to b. In calculus, we don't like really using x1s and x2s and x3s if we can avoid it. There's one time in the whole area of things, like in semester, where we will kind of have this notation. But for right now, we love, especially with like physics-y problems and like stuff moving with respect to time, we use A's and B's. And, well, you guys saw some of that in homework too, as far as just the A's and B's coming up. But this is a little different in that we're not talking about unknown A's and B's in equations, like the whole make it continuous or make it differentiable or find a tangent line there. This one is instead from beginning to end or from one point to another. So it could look like this. This is how it looked last year. Average rate of change, slope of a secant line, f of x2 minus f of x1, change in y over change in x. Rate slope going through the curve. But it could also look like this, which is a little more useful. Now, what on earth are they going to be asking us to do? Now, as soon as, uh-oh, we lost my position function. Sorry, I'm going to grab it. There we go. As soon as we see a problem like this, first of all, if you see, word problems in homework, so you guys didn't have me last year, so you didn't figure out how to summarize. Oh, summarize. What are you supposed to do in homework, guys? Summarize not only the directions, like find, whatever, but also summarize the given information. Here's a struggle. There's a whole paragraph on the board. How are we going to summarize this in our notes, let alone in our homework? That's not bad. What do you guys see? Tell me the important words.
150 feet.
Can you do like the ball drops problem? Ball drops, period, right? I could say initial height equals 150 feet. Height, colon, s equals negative 16t squared plus 150. S, colon, seconds, I guess. Find average velocity, right? We can summarize that. We don't have to write that whole paragraph. Ball dropped, period. Initial height equals 150 feet. Height, s equals negative 16t squared plus 150. And we have t being, or sorry, s being measured in seconds. Oh, you know what these that doesn't make sense. The s and t should be switched. Is that like actually written in there? Wow. S and t. T is measured in seconds. No one's ever found that typo before. Did anybody see that? No? Too early? There we go. T is measured in seconds. Not S. S is measured in feet. Okay, calculators out. As soon as you see decimals in calculus, almost always you're allowed to use your calculator. Go team. If we were to plug this into a formula, it says easy as, letter A, average velocity for all of these. Average velocity for all of these. For the first one, for A, can't I just do S of 3 minus S of 2 all over 3 minus 2? What do you guys think?
Yes.
Which would not be super nice if I actually had to go ahead and plug and chug it to this original equation and say, oh, state negative 16 times 9 plus 150 minus negative 16 times 4 plus 150. Could we do this? Yeah. Do we want to do it? Not if you're allowed to use your calculator. P.S. I said 3 squared is 9 and 2 squared is 4. Not if you can use your calculator. Do you guys remember how we use our calculator to simplify something like this? Where do we put equations that we want to use over and over and over and over and over and over again? Y equals. So throw this equation, negative 16t squared plus 150. If it is a calculator problem, you can make your life a lot easier. Anytime there are decimals, it's definitely calculation. Almost definitely. So throw this in. I have my, let's get rid of him. Let's get rid of him. I don't know if you guys have them. Get rid of anything you have. Negative 16, we gotta use an x because we don't have a t plus 150. I'm just reminding you of a couple tricks in your calculator. Get out of there. Don't go to the graph, that'll make life harder. Do you remember there's a cool alpha y equals fraction trick?
Yeah.
No, if you didn't remember that, hold on, I got you. So remember, you can follow my buttons down here below, right? So you can go alpha, y equals, enter. Oh, but I did too many fractions, bummer. I'll do it one more time, alpha, y equals. Okay, why am I doing that? Well, because I have my nice little 3 minus 2 down here below, and what do I have up above? I need my s of, hold on, where's my s again? I can go to alpha, trace, or alpha y equals, and then go over on the menu buttons until you get to this last one. These are all the little hidden menus. Y1, function notation says, if you can, give me the name, and then tell me who to plug in, I will. And the calculator knows it, which is pretty awesome, because then you're telling it to go to that function that you have stored in Y1. And I can plug in 3 and plug in 2 and say, that was easy, -3. Right? So use the trick, either on your calculator or your group's calculator. Can you guys find for me the other two? It is awesome. The most important thing is to know your formula. Ready, set, find me all the velocities. Ooh, all the average velocities. I'm going to set up the formulas, but you guys plug each other. Someone who has letter B, let me hear it. Wait, you guys have the procedure down okay? Shouldn't have taken that long. So you're doing your little alpha y equals enter to get your cute little fraction. You're going to your alpha trace, if you're going the fast way. Your alpha trace to get your y1. And then you're plugging in whatever you need to plug in. What did you guys get for B? Oh, be louder, it's okay. 0.6? It's even? Or, we always should have 3 decimal places in calculus, so I'm just making sure it's actually 0.600. Okay. And then for letter C? Be careful. If you're not doing that nifty little fraction you do, some of your calculators can't do it, and some of you don't like it because sometimes it gives you fractions instead of decimals at the moment. Just make sure that you're doing a parenthesis around numerator denominator if you go ahead and do it that way. And then get your y1 of, for instance, or what we just do, 2.01, I think, minus. And some of you guys might have a calculator that if you go to do this, there is no hidden menu. There is another way to find this y1. But you also wouldn't have the ability to do this cool fraction notation. So I'm just showing you if you're doing it the old-fashioned way, you have to hold in the numerator and then divide, and you have to hold in the denominator. You should get the exact same thing. If you're getting something different, maybe your y1 equals is written a little bit off. And if you have an old calculator, before the AP, we want to get you a new one for a lot of different reasons. It makes life easier if you have the old one with a yellow button for the second. But you can find the y1 by going to bars and then over to y bars. We're in function mode, that's where that y1 is hiding. So there is like a long way to get there, a non-shortcut way to get there, and everyone's calculator, bars, y bars, function. But most of us hopefully have ones where we have that hidden menu because our calculator is able to handle the updated operating system. So, what do you guys notice about our intervals?
We're getting closer and closer.
Really? That's like 1 second gap, that's a 0.1 second gap, and that's a 0.01 second gap. What am I getting closer and closer to again, Kyle?
2.
2. What are my units for velocity? Just in context of the problem, what would you guys say? And if worst comes to worst, think about the highway. Think about if you're a driver. Think about speed limit signs. In America, aren't they measured in miles per hour, distance over time?
Whoa.
Whoa! If you were in almost any other part of the world, it'd be kilometers per hour. But either way, distance over time. So what's distance in this one? Feet. Oh, hey! Aren't S's positions and aren't positions feet anyway? Oh, okay. Feet. And then what's on the bottom? What are these guys? X's, and X's are T's, and T's are seconds. So each of these are feet per second. Now here's a weird question. How can the rate be negative? Going like backwards in time? Black hole? Is this average speed or average velocity?
Velocity.
What's the difference between velocity and speed?
Direction.
Direction is included in velocity and not included in speed. They both have to do with rates of change. They would both be measured in feet per second. But guess what the average speed would be for A? Oh, do you guys know what magnitude means? The how muchness? The magnitude of -4 is 4. The distance of -4 away from 0 is 4. The magnitude of -72 is 72. The magnitude of 13 is 13. What's magnitude a lot like? Absolute value. So what's the average speed in this problem? Just 80. How about that one? 65.6. How about that one? Speed says how much, how high is your rate. Velocity says not just how much or how high is your rate, but also in what direction. Also in what direction. We'll talk more about direction in a bit. But the directed rate says, in the negative direction, whatever that means. But how fast? You're not going backwards in time. You're just going backwards in position. All right, so average velocity is the average rate of change, except from pre-cal. But you can use your calculator definitely to make things easier when possible. So how does that change from instantaneous rate of change? Wait! Isn't that one of the 3 different descriptions of a derivative?
Yeah.
I'm glad you guys write that down. I think we've seen this back here in the definition of derivative. You guys look online where all your forever cards are up to date as well. Maybe everything but the basic rules. I don't know what definition of derivative. We have for the delta x definition, or we have the h definition, the limit definition of f prime of x. 0 by zeros, we can keep going if we have to, but what's the description of the derivative? Slopes of tangent, slopes of graph, instantaneous rate of change. So when I see instantaneous velocity, which is an instantaneous rate of change, all I need to do is find the derivative at a particular x value. And now that we have these really snazzy shortcut rules, is it going to be near as hard to find f prime of a now? No, because I can use the power rule, I can use the sum and difference rule, I can use the constant multiple rule, I can use all of those things from competition yesterday. To find the derivative, all I have to do is plug in x equals a at the end. Now guys, this is important because you have done f prime of a, you have done like slope of tangent line at, or instantaneous velocity rate at, with limits, because you need to use limits anymore. Nope, because we have moved on from limits. We haven't moved on from what a derivative is. We haven't moved on from what a derivative does, but we have moved on from limits, because now, what's that card that I just had up a second ago? We have basic rules. So finding derivatives are a whole lot easier, a whole lot faster. We still need to plug in at the end. If we're trying to find, we can use those. If we're trying to find an instantaneous rate at the point. And how does that change? Well, instantaneous rate, if we have some sort of curve again of our position, for instance, we call that S of t. And if I have some sort of A, for instantaneous rate, says take that A, go to that point, undo a tangent line. Hey, quick reminder, tangent line, not that that's going to be the forever part, we already have a forever part of that, but how do we do an equation of a tangent line, guys? Because some of you got stuck on this in homework, so we're going to need to talk about questions or places you got stuck in just a second. How do I do a tangent line again? Y minus y1, which in this case, wouldn't y1 be f of a, right? Y minus f of a, that's the y value of the point, equals, how do I find the slope of a tangent line? The derivative at a, and then what's my special x value? If I ever need to find my tangent line, remember I can. Okay, so here's my forever number 11. This is what we had to get up to. And then we'll pause and we'll work on more examples tomorrow. And go talk about the places you got stuck in homework last night. You can see them today. So, if you hear position, and if they don't give you a letter, you're probably going to be using either S of t or X of t. Technically in future math, it could be Y of t also. It could be other stuff as well. But if you want to think about it, last year we saw X of t when we were talking about parametric equations. Don't worry, this is a B, C thing, not an A, B. Parametric equations let us define something in terms of time by using both an X and a Y. Both in terms of t, there was that par mode in our calculator. Basically in AB, we're like, okay, using both of them at the same time is too hard. We need two-dimensional motion, something that could be going based on time both out and over. So we have our X and we have our Y, and our T is like this third weird awkward variable that's not really on the graph. In AB, we're like, no, it's too hard. So instead of doing both at the same time, instead of doing horizontal and vertical change, instead we just do one-dimensional motion. You're just going right, left, like on a straight track. Or you're just going up, down, as in like dropping a rock. We're just doing one-dimensional motion, so instead we're just doing like T. And then it could be an X, it could be a Y, it could be an S, it could be all sorts of stuff that would make time a dependent variable, so we're not doing the crazy two-dimensional motion. But if you look up here in the Endeavor cards, well, the Endeavor cards, the BC kids have to figure out, well, how do we deal with both at the same time and take a derivative with both of these parametric equations, and how do we do a tangent line with both? Anyway, they go a step harder, but we just did what we call one-dimensional motion. So you want to think about it, this X of t is saying, let's not do both of the parametric pieces, let's just look at one. Let's just go in a straight line, either right, left, or up, down, horizontal or vertical, that's it. So average, we just wrote this down a second ago, that's from pre-cal. F of B minus F of A, all over B minus A. Average, that's over an interval, from a beginning to an end. Instantaneous, that's at a point. At, we'll do T equals A, although it could be, that's nasty. It could be not a T, but that's okay. And that's just our F prime of A. Wait a minute, hold on. But velocity is rates of change of position. So am I wrong in saying, I don't know, whoever your function is, I'm not wrong, but didn't we just say that we're going to be calling position either S or X, right?
Yeah.
Okay. So just for sake of argument, if velocity is the rate of change of position, or whatever function I have, to make it specific for our motion card, we'll say, okay, specific to this example, velocity is looking at the rates of change of this dude position. So if a bystander or an observer is off to the side watching you and your car drive, or you can think a cop on his motorbike has a radar gun, trying to figure out how fast you're going, he's trying to see how quickly your position is changing, because he can't see your speedometer. Only you can. speed is the absolute value of velocity. So we've already said that velocity is equal to S prime of A. Velocity is equal to S of B minus F of A over B minus A. Depends on average versus instantaneous. If they don't tell you which one, it's assumed, if they just say velocity, it's assumed to be instantaneous. Average, they have to ask for it specially. So I'm going to put the V of A over here on the instantaneous one. If they don't say otherwise, V of A, the velocity at some time, is talking about the derivative. Acceleration, well, he can be directed also, so I'm going to put a little directed. He has a positive or negative talking about in what direction his rate of change is. But he's actually the rate of change of velocity. So ooh, that's awkward, A of A. Can I put at C? Is that okay?
Yeah.
My acceleration is going to get messy right about now. Let's do X. I know, I'm sorry. You should say. I mean, don't. Please, but V of C is equal to S prime of C. It's okay, I'm not changing that much. Absolute value of V of C or absolute value of S prime of C. Acceleration, yes, it's directed. Should have thought through that before I kept going. Sorry, guys. A of C is equal to V prime of C is equal to S double prime of.
Ew, stop it.
There's two. Why is there two of them? Because I'm quoting somebody. Nope.
No.
Okay, well hold on. Who's little a actually stand for? Why'd I have to go back and change everything? Who is he? Acceleration. What is acceleration? Can you guys see it? What is acceleration? The rate of change of. Who is? Velocity. Okay, so acceleration is a rate of change of, derivative of velocity.
What is the double prime?
And velocity is the rate of change of position. So isn't acceleration also the, ready, rate of change of the rate of change of position?
Excuse me?
It's a rate of a rate. Now, it's not that hard in your car, is it?
I don't think so.
Hit cruise control.
Oh.
Are you still moving?
Yeah.
You're, oh.
Yeah.
Usually.
No, yeah.
I hope so.
No, just being argumentative. Okay, so you hit cruise control. Boop, you're still moving, right? Is your position still changing?
Yes.
But what's your acceleration? None. Unless you're on like a hill, flat. Okay, so cruise control, your position is changing. You're going at a certain mile per hour, right? If you're going 80 miles per hour, the cop could still stop you. I was on cruise control. Who cares? You were still going 80, right? My acceleration was 0. Who cares? But what happens when you take off cruise control and either you start decelerating, and then, or you start accelerating? What changes? Your position's been changing the whole time. Acceleration is not changing your position. Acceleration is changing your speedometer, right? Your speed. So you know this. Acceleration is how fast your speed is changing. What's gunning it versus not gunning it? If you gun it, what are you doing in the car?
You were breaking the gas.
You're jamming on the accelerator pedal, right? You're hitting the gas, right? There you go. Okay, if you're gunning it, what are you trying to do to your speed? I was doing it this morning when I was trying to merge onto the freeway, and there was a huge semi that was not changing lanes. And I was like, you gotta be kidding me. And it was a very short merging lane. Why was I gunning my engine?
You can get in front of it.
So that my speed would speed up quickly. I have an old car. It doesn't do it so well. I gotta like, and then even then it's kind of rough. And he ended up, yeah, it was a little close. I was like on the shoulder and trying to, I didn't put them on. It's all right. I just thought about it. Anyway, so coming back. I know I have too many side
I think
effects.
it's fine.
It's
I survived. I made it here. But long story short, it's a really annoying merge thing. That's where I started. Coming back. Anyway, why do you gun the accelerator pedal? If you want to speed up quickly. Acceleration. It makes sense in the car. It needs to make sense in problems. It's the rate of change of position changing. What? It's the rate of change of position. Now, it's a lot easier to say, okay, it's velocity's rate of change, but we can actually say it's the rate also. Anyway, so who's this dude? Second. Yesterday, what were we finding the entire time? Derivative competition. Finding the derivative. Who's the first derivative? Which means now there's a second derivative. Which means there might be even a third derivative. Ask BC kids about what jerk is. Not who jerk is, but what jerk is. Anyway, coming back. That's what they want to put in their sweatshirt. We'll see if it passes. Motion problem solving clues for free-falling objects. Guys, these are things that are going to be really helpful in the word problems for the homework that's tomorrow night due on Thursday. So we could say, hitting the ground, my position is 0 because you're on the ground, splat. Although in physics, you can actually make it like a negative or something. Anyway, we'll stop. Initial, that means at the beginning, aka time is 0. Well, maybe you start something initially at 9 a.m. So okay, time is at the beginning. Time is at the beginning, whenever the beginning is. Maybe it's the 0 with hour, but maybe it's something else. We'll just say beginning. And dropped might not make much sense, but the initial velocity is 0 because you're not throwing it. All you're doing is dropping it with no initial push or force. Although gravity pulls it down. Gravity is acceleration, and that's kind of complicated. But anyway, this is forever card number. Why was I making sure to get you this forever card today? So I didn't want to give it to you tomorrow and then be like, hey, it's on the forever quiz. Yay. Anyway. All right, forever card number 11. Let's go grade homework. I know, we're getting close on time, but that's all right. We did a great job today. Wait a minute. What can we do tonight for homework? This is so sad. We have no homework to do because we haven't done many examples. Depends on how physics savvy you are. Because there's going to be stuff like situations of things that are in motion, things that are moving, things that are changing with some sort of position function, saying stuff like how long is it in the air? What's the velocity when it hits the ground? And you're going to have to do things like derivatives sometimes, but other times you're just playing around with the situation, which is why we need to do examples tomorrow. So some of you, tonight might not be a good calculus homework night to get ahead. Some of you are like, physics doesn't scare me. Vectors last year were easy cheesy. Don't worry, they're not vectors. I'm just talking about how your brain works. But if physics is not your thing, at least if you don't think it's your thing, then just don't do homework, catch up on other stuff, and then be ready tomorrow. But let's grade. Number 2, A is -1/2, B is -1. A is -1/2, B is -1. Number 6, it says easy as, oh, they use y prime? Poor Leibniz, dy dx. Anyway, 12 times x to the 11th. They're like stealing Leibniz's notation, too, and making it Newton. I wonder if there are politics in your book. Anyway, number 14, 2t minus 3. I guess it is kind of like 400 years later. Probably not a big deal. Number 18, 6x squared plus 12x. Oh my goodness, they were all power rules. Didn't I give you some nice easy evens?
I liked it.
This table is gorgeous, guys. It's gorgeous.
This is the hardest part. I have a question. I was on this for at least half an hour.
That's good, though. Okay, so the table.
Wow.
The table. If you want out of the entire table, the trickiest ones, it's kind of like all of them. But the most tricky ones moving forward would probably be 25, 26, 27.
Really?
And even after you've been doing calculus for a while, people forget. The 7 is just a 7. The 7 is just a 7. You just steal that x, make them a negative, and then boop, 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 done. The 2 is just a half. There's the 5 still, I know. But the x is to the -2, not the 2x. Just the x is to the -2. And then power will boop, boop, boop. You're welcome. However, this guy, okay. This 5 was being raised to the 3rd power in the denominator. But do that first to get coefficient power will boop, boop. There we go. Pi is just a constant. 29. Oh, come on. I prepared you for that, didn't I? Did you guys subtract the powers first and then do powers? Number 30.
I know the easiest one.
Ah! How about 30? I thought he was the easiest one because you just pop him up and say power rule. Oh, I struggle. Now hold on. If you guys notice, I just showed number 36. Maybe you have time to grade and maybe you don't. But do we have more evens? Yes. Do you see how I'm still going in the video? Why am I still going in the video if there's no way that you have time to check it? Can you guys finish grading your homework tonight and then come tomorrow with questions? Sound good?
Yes.
All right, cool kids. You just need to go in the video at the very end of class. Pause it.